Hello, thanks for your interest in the population lines viz, and also thank you for taking the time to have a brief look at how it was created in Tableau. So the idea, I have to admit, is actually not mine. This was actually an idea that James Cheshire from the Center for Advanced Spatial Analysis at the University College in London had when he was asked to design a cover for a conference handout. And he basically back then in 2013 created this really nice map visualization, which was pretty critically acclaimed back then. And it actually saw a renaissance only a few weeks ago when it suddenly popped up again in my Twitter feed and also in my blog reader, when another colleague of the name Henrik Lindberg made a very similar viz, actually exactly the same viz. He just used a different data set and basically recreated James's code. And the nice thing, or the geeky thing about Henrik's code was that he actually managed to do the same thing in just 16, I think, lines of code it was. So that's actually a great thing. Okay, let's have a look at what it originally looked like. So this is James's website, and I highly recommend you to have a look at his website anyhow, not just for the population lines project, but in general because he has some really interesting and awesome content on there. So if you're interested in any types of GIS, geographic or spatial data analysis or R coding, I highly recommend his website and also his books, by the way, which are really good. So this is basically the post where James, after the renaissance of his map, after Henrik posted his version, actually explained a little bit of why he created it, and he also posted the original R code that he used to create the original visualization. And you can see it's kind of longish, although it's pretty concise nevertheless. But like I said, the interesting thing was that Henrik then managed to actually put exactly the same idea into R or into a little bit of R code, and he managed to do it in what's only these few lines here. So it's basically, well, 17 minus the two empty lines. And the interesting thing is actually all this thing here, if you're familiar with the whole piping thing and the McGriddle thing in Tableau, in R, this is basically just one line of code. He just broke it up so it's a bit more legible for humans, but from a computer point of view, this is just one line of code, and he's using extensively this pipe symbol to kind of connect all those different commands. So that is the viz that he created, and as you could see earlier, James actually had used worldwide population data for his visualization. Here we go. So this was a worldwide population map. Henrik, on the other hand, opted for just showing the data for Europe. I was, well, actually, when I saw this map popping up again and having been working in and with and for Tableau for a while now, I said, okay, that's a great challenge. Why not rebuild this in Tableau? And I set out to do this. So I actually wanted to start with James's version of the worldwide population. The problem is the data set that he references, the NASA CDAC data. That is actually, it seems to be a great data set. The problem is I registered the website, I never got the confirmation email, so I actually never was able to download the data. So that's not a bad thing, I guess. So instead I used the data set that Henrik uses in his visualization, which is Europe, which is closer and nearer to my heart anyway. So I guess it's a good starting point. The place to find the data, and by the way, all the links that I mentioned here and that I show in the video will be in the accompanying blog post as well. So the data can be found here on the Eurostat website, which is basically just the European statistics published by I think it's the European Commission. And if you follow the link, you will end up at this website, and up here you can download the Geostat gridded population. 1K stands for 1 kilometer grid, so it's basically a gridded population for, like you can imagine, virtual 1 kilometer grid cells. And we're using the most recent data, which is already 6 years old, but it's okay nevertheless, I guess. 2011 is fine. So that's basically a zip file, and if you download this, you will end up with basically in the zip file there's two CSV files, so I just put them here in my download folder. And now let's get to work, should we? So I have a fresh instance of Tableau here, and so first of all, let's load up the data. So like I said, there's two CSV files. I don't really know, and I couldn't find an explanation why they're being split in two, but we will need both of them. Luckily, they are following the same structure, so we can use the nice union feature, which we have in Tableau. But for now, let's just open up the first one. You can see I'm having a bit of a problem here because my system locale of my machine is in German, and that does conflict a little bit with the comma being the column separator, but in Tableau we can very easily change this using the text file properties and setting the locale to English. In my case, I'm using the United States. And there we go. Tableau picked up the column names very nicely. Let's have a brief look at the data. And there we can see it. So we can see this is the total population for each of the grid cells. Each of the grid cells themselves are being referenced by a kind of strange nomenclature, but we can easily split this as we will see in a second. And then there's a whole load of other information which we are not going to use in this case, but if you're interested, you can just have a look at that as well. So now, like I said, let's use the new union feature in Tableau to union those two files together. And the way we do this is we just drag it down here. So this little box appears, drag table to union, and we drop it on here. And just like this, the two tables are being joined and we have the whole data set in one table. So that's nice. Okay, now like I mentioned, the grid cell format here, that's a bit of a problem because Tableau can't really put this on a map. So what we now will do next is to split this up. Basically what we need is, out of this text information here, we need two pieces of information, one being the longitude and the other one being the latitude. And maybe you can see it already here, there's an N followed by 4 digits. That's basically our longitude. And then there's an E followed by 4 other digits, that's basically our latitude. Okay, so the easiest, in my opinion, the easiest way to parse out the numbers is by using regular expressions. If you're not familiar with regular expressions, don't worry, this might look a bit cryptic, but it's actually not that difficult. And there are great learning resources out there for you to kind of understand how this works. And I will try to explain how I built these regular expressions, so I hope you will be able to follow. So let's start out with the latitude. That's what we're going to call our field. And we are going to use a function called regex extract. So we are going to extract something from a text field using regular expressions. And the way this works, as you can see, is first we need to put the string, which is where we are going to extract from. And the second is the pattern, enclosed in quotes. So what are we going to write here? So basically what we're interested in for now is those 4 digits after the N. So how do we get them out? Well, first of all, there is a number of random characters, which we are not really interested in. That's denoted in regular expressions by a dot for any random character and a star for any number of them, and followed by the capital letter N. So that's actually a literal N. Then there are the 4 digits that we're interested in. So what we're interested in has to be enclosed in parentheses. So I'm just going to, for now, write the parentheses. And we need to tell Tableau, or the regular expression, where to stop extracting the digits, right? So the first character after the 4 digits that we want to extract is an E in this case, but we need to be careful because in Europe we have coordinates both east and west of the central meridian, so we need to make sure that both E and W is recognized at this point. And the way we do this is we write E and W in square brackets, and that basically means the one or the other. And after this, there's again just a number of characters which we are not interested in at this point. Okay, so we're almost there. Now we just need to tell Tableau within the brackets what to extract. And the thing we need to extract, or we want to extract, is basically 4 digits, or it might be any number of digits. And the way to write a digit is basically, again, just a square bracket for any of these, and then write 0 to 9. So it can be anything 0, 1, 2, 3, and so on, up until the 9. So that basically makes up all the digits there are. So that's it. That's our regular expression. As I said, it looks a bit cryptic, but it's actually pretty easy if you work through it step by step. Now, first of all, make this a floating number. So it's like a number that has decimal digits, and just divide the whole thing by 100. Calculation is valid, and you will see in a second why I'm dividing it by 100. If I just click apply here, you can see, actually in this case, there was a mistake. Where did I go wrong? Oh yeah, I made a little bit of a mistake. So actually, because if we leave it this way, Tableau would look for only one digit, but we actually want to look for a number of digits. So in order to have a number, an undefined number of them, we just write a plus. If you're interested in the difference between a plus and a star, I'm not going to talk about this here. Just look up a reference for regular expressions. That should be pretty easy to understand then. The key word here is it's non-greedy. So that's the result I expected. So now we just basically extracted the 2, 6, 8, 9 from this one, for example, and converted it to a floating number of 26.89. So that's very nice. We're done with the latitude. And let's do the same thing with the longitude. And I'm not going to explain everything in detail again because it's pretty much the same. Only in this case, we have a number of characters up until the E or the W. So we're just going to write dot and a star. And then there is the E or the W. That's the one we kind of want to stop having the random characters. Then there is the undefined number of digits. So that's the 0 to 9 plus. And we wrap it in brackets. So we show Tableau that this is the stuff that we want to extract. And after that, there's actually nothing. So we can leave it like this. And then again, we will wrap this one in a float. So we make a floating number out of it and we divide it by 100. And we're done. Or are we? Actually, in this case, we're not, because as I said, we have values both left and right of the central meridian. So we do have eastern and western coordinates. If we just extracted it like this, the information, is it east or west, would be lost. So we kind of need to account for that. The cool thing is if we think about it, it's basically just positive or negative numbers. So if you go to the east of the central meridian, it's positive numbers. If you go to the west of the central meridian, it's negative numbers. So basically what we can do here is we can say multiply by -1 if west. So if this character here, which in this case is an E, if that's a west, then just multiply it by -1. And the way we do this is we just extract another piece of the regular of the grid ID. And if you followed me so far, you're probably going to figure out pretty easily what that's going to be. Basically, what we're going to do is we're going to extract exactly this letter. Okay, and the way we're going to do this is have a random amount of stuff. Then there's something we want to extract, which is either an E or a W. That's why we enclose it in square brackets, enclose it in parentheses, and then after that, there's again a number of stuff that we're not interested in. And the divided by 100 goes after it. So basically, now that is either an E or W. And based on if it's an E or W, so we just compare this stuff to west, let's say. It doesn't really matter which one we choose, it just has to be one of them. If it's a W, then multiplied by -1, otherwise multiplied by +1. If that was too quick, just rewatch this part of the video or have a look at the formula in detail. Just download the workbook, have a look at it. It's actually a pretty simple concept. It's just regular expressions always look a bit gnarly, so just give it some time and look over it a few times. I'm pretty sure you can easily understand it. Okay, the good thing is Tableau says the calculation is valid, so we can just apply that. And let's see, maybe in this case there should be a 43.37 coming out of it because it used to be East 4337. And there we go, 4337. Perfect. So those are basically our latitudes and longitudes, very nicely. Okay, so that's nice. So now let's give it a test. Let's open up our first worksheet. Since I want to map those or put them on a map, let's change them the default aggregation to average first. And let's pause the rendering. This is actually a very useful button if you hadn't seen it or used it so far. Whenever you work with a lot of data, like in this case, you'll see it's about a few million rows. So every time you want to refresh the viz, it's going to take a few seconds. If you don't want to wait that long, just pause the viz refresh and build your viz without Tableau rendering it. Like in this case, the average longitude on columns, average latitude on the rows. Let's change the visualization type to a circle. Let's actually make it a lot smaller so we can see the single circles. And let's also put the total population on color. So before I click go, what we should see next is a map of Europe with the population being represented as colors. Okay, let's go. Okay, the reason we don't see it yet is because I forgot one very important step. Actually, at the moment, we just aggregated the whole population of Europe into one point, which is 533 million. That's obviously not what we wanted to do. What we do want to do instead is to break it down by the grid ID. So we just drag the grid ID onto detail and select all members. And this might take a little bit of time because now we are rendering a large number of points, which is not something that's very meaningful or useful, but it can be done in Tableau. So let's just have a test. And there we go. That should look familiar. That is Europe. And you can see, I mean, it's a little bit hard to see, but you can see some of the major population centers, like you can see London down here and Paris and Madrid and so on. I think you can discover Berlin up here a little bit. So that's just a sanity check that everything we did so far was correct. So we can just very easily remove this. This was just a check. So the thing is, as you saw now, our data is in a very high spatial resolution. And if you think back on the original visualization, let me show you what it looks like. You can see that the actual grid lines have kind of a gap between them. So we do not want the spatial resolution of our final viz to be in the 1 kilometer resolution that our data is. So what we need to do in order to get there is to group the data even further. So far what we did is, let me just open up the longitude. What we did is to divide it by 100. So that gives us, or that actually cuts the data at a 2-digit floating number. What we can do now is, in order to group it closer together, we can just round it off at the first digit. So I'm just going to wrap the whole formula in a round comma 1, and this is basically just going to round my latitudes, and I'm going to do the same for the longitude. It's just going to round my numbers to only 1 digit. So let's see, and put it all the way in the end, comma 1, and close the brackets. Calculation is valid, that's always a good sign. So now we basically have our latitudes and longitudes grouped. So that's nice. So now that we have this done, we can actually start building our viz. And this is actually a thing that I should mention. This is where I was kind of stuck. I mean, I was able to build the viz, but it didn't quite look the way I wanted it. And the reason was, as it turned out, and that's where I have to thank my colleague and data rockstar Johanna Knapp here from the German Tableau team. She pointed out that the problem was actually that I made my latitude and longitude fields, I assigned them the geographic roles of latitude and longitude, which, I mean, was obvious to me that I should do that because they're latitudes and longitudes. The thing is, since this EU data is in a kind of a weird projection, it didn't make sense anyways, because you couldn't match it to the map that we're using in Tableau unless you like would have to reproject it, which you can do, but I didn't really see the point because I didn't want to put the map underneath anyways. So actually there was no reason to assign it the geographic roles of latitude and longitude, and as it turns out, that was actually what prevented me from building the viz the way I wanted to do. So here's my tip for you: don't assign geographic roles to your fields latitude and longitude, because this is going to break your viz in this case. What we do need to do though is to make both latitude and longitude dimensions. What we're going to do next is not going to work if they are measures. So I'm just going to select them and drag them up here to my dimensions. And just like this, I converted them to dimensions. Now, there's one more thing missing, and that is, if you think back to the original viz, how did James and Henry create those spikes? Well, basically, it is the latitude, and then on top of this, they added the population for each of those accumulated grid cells. So you can imagine each point along those lines represents a number of grid cells. Remember, we merged them together using the round one function. So there's actually multiple up to 10 cells being aggregated into one now, and the population of those up to 10 cells, actually it's 100 cells because we have 10 by 10, sorry, up to those 100 cells is being added together, so we know how many people are living within each of those aggregated grid cells. And what they did is basically just shift the latitude position of each of those points along the lines by how many people are living within this aggregated grid cell. That basically creates this, well, it's not really a 3D effect, it's a kind of 2.5D effect of the spikes like coming out of the surface of the European continent. Okay, so that's actually what we're going to build next. And the way to do this is create a calculate field. I called it height in my case. Obviously, you can call it whatever you want. Now, like I said, we are working with the latitude. We are adding something to the latitudes. And since we have aggregated latitudes now, we actually have to work with an aggregate function. So in this case, let's use the max, for example. You could also use the min or the average. Just don't use the sum. That's not going to work in this case because we cannot sum them up. We just have to pick one of them. And to this, we want to add something, like I said. We want to add something. Now, what are we going to add to this? Basically, what we need to do is we need to figure out what is the most highly populated grid cell. And the way we do this is a window function or a table calculation, which is a window function that is the window max. Okay. And the window max of what? The window max of the sum of population. Let me break this down again. So basically, like I said, using the round, we aggregated up to 100 original 1 kilometer grid cells into one of my, let's say, visualization grids. And we need to sum the populations of all those original grid cells. So that is the sum of total population. And in order to find out which is the most highly populated grid cell, we just use the window max function. And in order to find out how high should the peak at the current grid cell visualization grid cell be, we just need to divide the sum of the total population within each of the grid cells. We need to divide it by the absolute maximum number of people, or the absolute maximum sum of total population of all the visualization grid cells. Again, this might look or seem or sound a bit difficult, but it's actually a pretty simple concept. We're just normalizing it. We're just normalizing the population of each grid cell by the number of people living in the most populated grid cell. This would actually work. The only problem is the spikes would not really be visible. So in order to make them visible, we are just going to use a scaling factor. I'm using 5 here, which is the value that Henrik also used in his European map. I'm pretty sure it's not going to work with the number 5 if you use the global population. So just play with it yourself and find out which is the scaling factor that looks best to you. All right, so this is our height. And now we can actually start building the viz. And in order to do this, I'm going to use my pause button again, which is very useful when we're dealing with bigger data sets. And I mean, this is not really a big data set, but it's still in CSV files, which are not the most performant data format. So let's just pause the rendering for a second and build our viz. So basically, what needs to go on the columns? On the columns, we need the longitude. And if we would build the latitude on the rows, we would basically just get the map of Europe. But we don't want the map of Europe, we actually want these spikes. So remember, within the height field, we actually used the latitude. So that is actually great because it has the latitude of the visualization grid cell shifted by the scaled number of people living within this grid cell. And we also need the latitude. So in order to have this in the viz, we're just going to put it on detail. And there's two more things we need to do. The first one is we need to change the visualization type to line, because after all, it's called population lines, right? So that's our visualization type. And then, of course, since we are working with a table calculation here, we need to tell Tableau how to calculate the table calc. I'm actually not going to do this now to show you what happens if we don't set it correctly. So I'm just going to click play now and see what happens. And we can see, well, first of all, look, this looks a bit weird. So let's just make sure everything fits into the entire view. That doesn't look half bad. Let's just change the size of the line so we can actually see what's happening there. Okay, so we can see the rough shape of Europe. So that's good news. We're almost there. But you can see it looks very, very weird because, like I said, the height calculations just not working correctly because we didn't tell Tableau how to create or how to calculate the window max. So let's do this quickly. Let's just edit the table calculation. Let me get the dialog. And what we need to do, let me move it here so we can actually see what's happening in the background. We need to tell Tableau to calculate this both for the longitude and the latitude. So you can see if I check both of those checkboxes, presto, our viz looks exactly the way we expected it to look. So this is the correct setting. We need to calculate to compute the window max both along the longitude and the latitude. All right, so this is it. There we are. This is our population lines. Now there's just a few more cosmetic things we can do. For example, let's change from the default blue to maybe that gray looks good. And let's also remove the grid lines. We don't really need the grid lines in this case, so let's just use the new workbook formatting feature that we introduced in Tableau 10.2. Okay, and let's also make sure that all the other um, things that we don't need, like an axis, for example, that they are gone, and also this null indicator down here, we don't need it. So that looks a lot nicer. And well, there you have it. This is basically your population lines visualization, the Tableau edition. Now, there's one more thing. If you're a geographer like me, you might frown upon the fact that this is kind of not following a real map projection. This is kind of distorted. Since we know that the original data was in a metric system, we can actually assume that the output should be a square in this case. Unfortunately, it's not really possible to set a square here in the Tableau worksheet. But what we can always do is we can create a dashboard, because here we can see here we can set the width and the height to exactly the same value, so that we get a square dashboard. And if we then drag out the worksheet and maybe also hide the title, that's basically the visualization we get. So there you go. I hope you were able to follow. I hope you like the result as much as I do. Feel free to rewatch the video as many times as you want to, or reread the blog article. Also, feel free to download the viz. You can find it very easily on my Tableau public page. So this is even like an interactive version, but you can always download the workbook to your machine, play with it yourself, maybe reverse engineer what I did, and also follow the kind of contrived functions that I introduced here. But I hope, like, if you followed along, they look complicated, but they're actually pretty easy. So don't worry too much about it. Yeah, like I said, I hope you liked it. Thank you for your time watching this, and I hope to see you again soon.